which router 1 believes router 3 is a part of. That's what we have configured on R1. So autonomous system 100, which is correct. We see that we have messages received and sent. However, we see the up down is 16 minutes and the state is active. So again, active is not good with BGP. We want it to be established, and we should see the state over here. When we have a good connection, we should see some prefixes being received as well. So again, the prefixes indicate networks that we're learning from our neighbor specified. So again, right now it appears as though we have a neighbor adjacency issue with our neighbors not forming a BGP neighbor relationship. So let's go to router 1. Let's do a show run pipe to begin with BGP, and then this is going to cut our running configuration straight to the BGP section, and then we can verify some commands within BGP. So we have the neighbor statement, which is the most important statement. First off, we need to have a neighbor statement towards router 3 with their IP address of the far side. In this case is 192.168.13.3, so it appears as though this internal BGP connection is running with the physical IP on the the physical interfaces, so we're using the IP address of the physical interface in this case. So that's good information to know, as well as we are using remote AS 100. So again, this is indicating an internal BGP connection because we can see from our BGP output that R1 is also in BGP Autonomous System 100. So the configuration looks good on R1. Let's go to R2 and take a look. I'm sorry, on router 3. On R3, if we go ahead and do again show interface fast Ethernet 00, we already were able to successfully ping from R1 to R3, so we know that our layer 1 is up, our line protocol layer 2 is up, we have the IP address 192.168.13.3/24 subnet mask, so that all looks good right now. So the next step is to do a show IP BGP summary. We can see that we have a neighbor statement for 13.1, which is router 1. So again, that part looks good. However, we see that our up down is almost at 20 minutes and the state is active. So we've almost been active for 20 minutes, and that is never good with BGP. We want it to be established. And then also you can see that the autonomous system for our neighbor appears to be 200. So we know, again, our trouble ticket says that configure the network so that R1 and R3 peer iBGP with each other. So what the show IP BGP summary statement is showing us in this case is that we have a neighbor statement under R3 for 192.168.13.1, which is R1, which is right. However, we're seeing that neighbor statement configured for the remote AS of 200, which is wrong. So again, we know that router 1 is running autonomous system 100. We already verified that on R1, which is here. So let's go to router 3. We'll do a show run pipe to begin BGP. And we can see that we have a neighbor statement under BGP 100 for R3. And our neighbor statement is 192.168.13.1, and then it says remote AS 200. So we know this is not correct. So another thing that you can do on the routers, which might be turned off, is logging. So again, whenever you're troubleshooting, you want to make sure you're logging your events. So what I like to do is we like to log to the console. We also like to do logging buffered. So what this is going to allow us to do is every time we get a message come up, if we do a show log, we can see now that we have events triggering and going into our log on the local router on R3. So again, we do this on R1 as well. We do a logging console so that we can see the messages on the console. Also, we can do a logging buffer to send those to the log. So if I do a show log, we can see that we have one event now showing up in the log. Now we see that we have two. So again, sometimes this might be turned off if you're in a Cisco exam, or if in real life, a lot of times network administrators and engineers will turn off logging just because of all the output that it could show up if you're doing some debugs and other events. So again, whenever you're troubleshooting, make sure that you're logging so you can check the real-time events as they happen on the local router. Because in this case, we can see that this has helped us out right off the bat, because we see that we're getting some error messages both on R1 and R3. R1 is showing that they received a notification from the neighbor 192.168.13.3, which is R3, and it says that the peer is in the wrong AS. And then we also see that on R3. We see notification sent to neighbor 192.168.13.1, peer in wrong AS. So it appears as though we have an issue on R3. Again, if we do a show IP BGP neighbor, we can, show IP BGP summary, we can see that our neighbor R1 is configured for Autonomous System 200 on R3, and this is false because we know R1 is in Autonomous System 100. So what we're going to do to fix this issue is we'll go under router BGP 100 on R3, and we'll do the command neighbor and then our neighbor IP address. Again, in this instance of internal BGP, we are appearing to the physical interface IP address to R1, which is 192